I have restarted. Can anyone confirm? Huh. Okay, so right now we will be using 720, and hopefully I can figure out if I can, because I think that as far as I can see, there are two options. So one option is it can be 720 and people can choose lower quality if they want, as far as I can see. And another option is 1080, but people cannot choose lower quality, which is quite weird. But I didn't figure out the setting to allow both choosing the quality and not having it, like having it 1080 available. So I think that today we will keep 720. It might be about being partnered, but I'm just not sure why these two options exist. So you can choose the quality now. I think that you couldn't choose the quality before, but maybe I'm wrong about that. But it's weird that you cannot lower the quality if it's 1080. Anyway. So problem B, which also contained an incorrect checker as far as I can say, as far as I could see. So we have an array A consisting of n integers. Each position I of the array is either locked or unlocked. And we can take values in the unlocked positions. We can take the values of the unlocked positions, rearrange them in any order, and place them back into unlocked positions. And we are not allowed to remove any values, add the new ones, or rearrange the locked positions. Okay. And we are allowed to do nothing, obviously. So we can just reorder all the unlocked positions as we want. And now consider the sequence of prefix sums of the array after the arrangement. And let k be the maximum j such that pj is negative. We want to minimize this position. Yeah, I can open solution to A. Sorry, again I get some questions. Sorry. Oops. Also the camera. So yeah, this line is what people ask something about. Sorry. Today's stream is not going well, but I'll do my best afterwards. To make up for that. There is no bits given option enabled. So far, no, but maybe in the next stream that will be enabled if I get Twitch affiliate. Forgot to mark problem A, correct. Thank you. Let's mark problem A. My name is Tourist, but which countries I have visited? Nice question, but I'm in the middle of the contest. So you can send your guesses on how many countries I visited. In the meantime, you can just send your guesses to the chat, and then we'll see who was the closest. Let's figure out this problem, and then I will read the guesses. So we have locked positions and unlocked positions. We want to rearrange all the unlocked positions to make the last prefix sum, the last negative prefix sum, as far as possible. No, not as far as possible, but okay. We want the last prefix sums to be, I mean, is it like, given that it's problem B, I would assume that I have just to sort all the positions in all the unlocked positions in decreasing order, but I just don't see the point of this problem. I would assume so, and then I guess we will discuss. The question was how many countries I have visited. At least one, yes, correct. That's a good guess. So we have array A and we have L, which means locked or unlocked. So let's make a vector of all positions which are unlocked. Sort them in decreasing order. And now it's also difficult for us to check the answer, right? Because multiple answers are possible, and yeah, we just cannot really check. But we can always submit. So let's submit and then discuss. Okay, accepted. Hopefully the checker is correct. Yeah, it's a weird problem because it's very easy to guess the solution. You can just try whatever comes to your mind, but then I'm not sure what percent of participants who actually solve this problem could prove their solution or something. I mean, given that also education rounds allow full feedback, but I guess it doesn't matter. Even in a usual Codeforces round, you can expect people to just try whatever comes to their mind and then maybe get accepted if they're lucky. The job of testing system is to test your solution. Just submit. Yes, correct. Okay, so what guesses do we have? We have 100, 50, 20, 38, 17, 12, 15, 16, 12, 21.37, 10, 8, 21, at least 1, 7, at least 6, at least 7, not more than 30. Okay. Should I just keep my secrets now and not say anything? That would be fun, right? Okay, so the solution is just pick all the unlocked positions and sort all the numbers in them in decreasing order, and then just write this number down in this decreasing order in the unlocked positions, right? And that's how we get the answer. But okay, guys, the correct answer is 27, as far as I know. So some people were close. I guess that not more than 30 is the best guess by OOSED. Not sure how to pronounce that. So congratulations, you won. So the proof. The proof goes as follows. Basically, it's the exchange argument, I guess. Yeah, as far as I can see in the chat. So the main idea is, suppose we have some array A1, A2, A3, A4, AN, right? So we consider the prefix sums, which are the sums of the first I elements, right? And we want to figure out what happens if we exchange two elements in this array. So consider two elements. So let's say that AI is less than AJ, right? What happens to the prefix sums if we swap AI and AJ? That's the question. And let's see. So P1, P2, and so on, Pi minus 1 don't change, obviously. Then Pi changes by how much? By AJ minus AI, right? Because we have changed the i's number, and basically we can also write that it actually increases by this difference, right? What happens to Pi plus 1? Actually, it also increases by the same number. If I is less than j minus 1, but whatever. So in general, all positions up to Pj minus 1 will increase by the same number. And Pj actually doesn't change, because we swapped two numbers, but both positions I and j belong to the prefix of length j. Actually, I wanted I to be smaller than j here, and ai smaller than aj. So, and we can also notice that pj plus 1, pj plus 2, and so on, pn, all of them don't change, right? So that's what happens. And it means that if we have two numbers, one of them is to the left of the other one, and the left one is smaller than the other one, if we exchange these numbers, then only all prefix sums can only increase. They can never decrease. Sure, I can mark B as done, but I am discussing B now anyway. So it means that all the positions can only all the prefix sums can only increase or not change at all. And so it means that if we have some array, some like answer array, some best result for this problem, some array which has the maximum j whatever, if we have any pair which can be exchanged which has this property, then exchanging this pair never makes our answer worse. It can only make it better. So it means that after suppose we have some best array, and then you can always make some operations of this type, and we do these operations until all the unlocked positions are in decreasing order. We can always, if the unlocked positions do not form a decreasing sequence, we can just pick any two numbers and exchange them, right? And we can just continue these operations, and eventually we will sort in decreasing order. And know that all these operations do not make the answer worse. So it means that we can always do that, and if some answer is optimal, then the answer with all numbers in unlocked positions in decreasing order will also be optimal. Yeah, this is kind of how the greedy exchange argument works. Yeah, kind of. It depends on the problem, but here it's similar, yes. Okay, so that's problem B. I guess we can move on. Problem C. Mortal Kombat Tower. You and your friend are playing the game Mortal Kombat 11, and can I submit this version with proof in the comment? Yeah, I don't care about the rank, so I can. But I'm not sure that many people will read it afterwards, but maybe. Okay. So we have n bosses numbered from 1 to n. The type of the ice boss is AI. So each boss is either easy or hard. So we have 0 or 1. Either you or your friend can kill 1 or 2 bosses. Okay. Actually, I don't think that my rank became worse. Yeah, actually, if I make an accepted submission after another accepted submission, then my rank does not actually become worse. So do you want to minimize the number of skip points? Okay. So this problem looks pretty educational, I would say. We have 2 people. Each of them can just kill 1 or 2 bosses, and we want to kill them in exactly the order we are given. And our friend can never kill hard bosses, but he can use skip points for that. And we can kill any boss. So yeah, it feels like a pretty simple DP. So let's see. So again, we have multiple test cases. And we have an array of zeros and ones. So we will do DP. And I would assume there are different ways. But we can do the more straightforward one, which has 2 arrays. So as I is let's say that him I is the smallest number of skip points required to kill bosses from I to N if it's our friend's turn to move. And as I is all the same if it's our turn to move. right? Why greedy will not work here? It could be, we'll see. Let's do the DP first. So the DP solution would be, we want to find these two functions. So obviously when we want to kill, let's say that we want to kill bosses from I to N, and let's say we have 0 numbered bosses, so him N and us N is equal to 0, just because to kill an empty set of bosses we need 0 skip points. And then we go from right to left, and for each position we want to calculate him I, and then we want to calculate us I. So us I is easier to calculate because we can kill any boss, so we just can kill 1 or 2 of them. And us I will be equal to minimum of him I plus 1 and him I plus 2. But here, if I is equal to n minus 1, we will have an array out of bounds. So to handle it, we can do, I think that the most explicit way, what I would do, would be like this. Only update the minimum if we can, if this bound does not go out. But we can do it easily if we just also, actually, we can just increase the size of the array and say that the n plus 1, like for n plus 1, we also have 0, but it's more of a hackier way. So I think that this way is more explicit and better in general. And for him I, it will be us I plus 1 plus, if our friend only kills 1 boss, we will have to kill, we will have to use a skip point for a hard boss, and hard bosses are denoted by 1s, so we just add AI, because we have to add 1 for hard boss and 0 for easy boss. That's exactly the type of the boss. And if again I plus 2 is not greater than n, then we make minimum of us I plus 2 and again plus AI plus AI plus 1, because we'll have to kill 2 bosses, I and I plus 1. And so the first person to move is our friend, as you can see. So we just output him of 0, because him of 0 is exactly this situation. Our friend is the next to move, and we want to kill bosses from 0 to n. So I think that should be correct, but we'll see. 2, 2, 2, 2, 1, 0. Looks good. Okay, accepted. Some people wrote about greedy. I'm not sure. What do you... So did anyone have greedy accepted? There is a very easy formula way. You can notice that the answer is just A0 plus sum of lengths of 1 sections divided by 3. Yeah, you can post links. But so I guess that the DP solution is, yes, it's actually the easiest one to just think about, because if the problem allows a simple linear DP solution, then you don't have to come up with any greedy strategies, just because this solution is pretty straightforward in the sense that you just don't need any logical deductions. You just implement what is basically asked. And I think this is quite instructive. But anyway, for some better solutions, it said that I'm not allowed to view the requested page, the page with submission. I'm not sure why that happens. Maybe it's because the contest is not over yet officially. And Yeah, for some reason I cannot open your links. Maybe the reason is that, oh, because I am during a virtual contest. Yes, so maybe I can open it in private mode. Yeah, okay. I cheated and opened it in private. Okay, so it's A0 because our friend will have to kill the first monster in any case. And then for the rest, we find all the sequences of ones, all the segments of ones, maximal by length. And for each such segment, we just add its length over 3. Is that correct? It would be fun to hack it right now, but really unlikely. Live cheating, yeah, during a virtual contest. So, I mean, in general, it's, I mean, this solution is probably correct, but so, I mean, obviously for a sequence, if everything was just once, then the answer should be the length of the sequence over 3, just because you want to your friend to kill one monster and you will be able to kill 2 monsters, so you just change turns. You kill 1, oh, you kill 2, your friend kills 1, and so on. But count over 3. But it's a bit unclear if how people, like, we have to make sure that we can always be the one to start the segment, right? And given that the lengths we can pick are 1 and 2, it can be proven, but it's not as trivial. Okay, so this is neat, but I would prefer DP over this. But if the problem actually made you to come up with this, then it would probably be a nicer problem. I would prefer a problem which would make you find this solution and not just implement the pretty brainless DP. Yeah, you can always beat 1 or 2 to get the correct parity, I guess. But anyway. Also, I cannot hack it right now because I'm in a virtual contest. So test case 011, 011, 011, 0011. I think this solution is correct and it will output 0. Because your friend kills 1, you kill 2, your friend kills 1, you kill 2, and so on. I think this solution is correct. Okay, let's move on to problem D. Vova decided to clean his room. The room can be represented as it's a very infinitely long room, but also infinitely thin. We have n piles of trash. Coordinate of the ice pile is pi. All piles have different, that's important, different coordinates. And the cleanup process is to collect all the piles in no more than 2 different coordinates. Okay. We want to collect the piles so we can move them to some points, right? So in one move, we can choose some x and move all piles from x to x plus 1 or x minus 1. And we can't choose how many piles he will move. Okay, just because we have to move all the piles from that position. And then we also have some queries, which is remove a pile from coordinate x or add the pile to coordinate x. It's possible that there are 0 piles of trash in the room at some moment. And we want to find the minimum number of moves after some queries. Okay, so basically we have to solve the problem. Basically, this could be what I would prefer for the previous problem, but actually, yeah, I just think that you could also add queries to the previous problem to make your solution, like to make people make some additional deductions, but actually people would not make those deductions. They would just do segment 3 DP, and that would be harder to implement, but not a better problem. And here it's a bit similar. So we have some positions. We want to move all the piles into 2 different points, and then we have some changes, and we want to answer the queries after the changes. All right. So there are no pictures, unfortunately, in this problem, but I guess you can imagine. Yeah. So this problem is definitely not as easy. So as of now, as of 43 minutes, we have 1,000 people solving C and 71 solving D. So one obvious thing is that we want to move some, like we want just to sort all the piles by their coordinate, and then just choose some position, some border, and then for all the piles to the left of this border, we want to move them to 1 point, and for all the piles to the right of this point, we want to move them to another point. Oh, yeah, I think that should be correct. Just because, like, so we just get all the piles on the left and just move them to 1 point, and get all the piles on the right and move them to the other point. But here, it's important that in one turn we can move all piles from position X to position X plus 1. If in one turn we could just move one pile, then it would be harder, I think. And just because, okay, let's move on to the code. So let's just solve a problem. We have some piles in positions P1 less than P2, less than, and so on, less than Pn, and we want to move all these piles into 1 point, okay? So if in one move we could only move one pile, then it's a well-known subproblem. We have to pick the middle point, P of, okay, let's say that we have 0 indexed positions, and we will just move everything to the middle point. Not the middle point, but the median point. We find the median of our array, and we have to move everything to this position. And the proof of this fact goes like as follows. So just consider all other points. Suppose we move the meeting point anywhere to the right or to the left, and consider how the total distance changes. But this is not what we need here, because actually in one move we can move all piles from X to X plus 1 or X minus 1, and it means that, for example, one way we can do it is just go from left to right and move everything to the rightmost pile. So if in one move we can move all piles from X to X plus 1 or X minus 1, I think that we need exactly Pn minus 1 minus P0 steps. And the reason for that is that we can always use exactly this number of steps, just going from left to right. We just choose P0. We move everything from P0 to P0 plus 1. We move everything from that position to the next one, and so on. And we just do a sweep from the left from left to right. But okay, suppose. But then it can be proved that we always need at least this number of steps, because consider the distance from the leftmost pile to the rightmost pile. And initially this distance is exactly this number. And in one step, this distance can only decrease by 1. And we want this distance to be equal to 0 eventually. So it means that we need at least this number of steps. So that's why we need exactly this number of steps. And finally, if we want to move everything, like, okay, all piles into 2 points, we have to pick some border position, I. Now we move P0, P1, and so on, Pi minus 1 into 1 point, and Pi, Pi plus 1, and so on, Pi minus 1 into another one. And we'll need Pi minus 1 minus pi P0 plus Pn minus 1 minus Pi steps. And this is equal to Pn minus 1 minus P0. We can write it minus Pi minus Pi minus 1. Okay? So this part does not depend on I, doesn't depend on the choice of our border, but this part does depend on I. And basically it means that to choose the border, we just have to pick 2 consecutive piles which have the maximum distance between them. And we will always draw the border between them. And is it maximum? No, I think it's the total. Not minimum, I think. Yeah. So we just need to find a pair of neighboring piles so that the distance between them is as high as possible. So let's do it. TT will be the number of queries. And what data structures can we use? We can actually use just sets, probably multi-sets. Okay, so we can use just a simple set for all the positions. Let's say it's P, right? And we will also use a multi-set, D, which will be the set of all differences. Pi minus P0, P2 minus P1, and so on. And so initially we will just, how do you do that? Yeah, so that's what I want. I think that the way to do it is to make 2 functions, which will be add and remove. And so we should add here. So D is the set of differences. So to add, we just insert it here, but we have to be careful. Okay. I'm not sure if there is an easier way, but I think that this way is fine enough. Yes, this should be log n per query. Okay. After we return, it should return a pair, as far as I understand. Let's check. Okay, so insert returns a pair consisting of an iterator and a Boolean value set to true if the insertion took place. So we can assert that we actually added it correctly. But now we know that the iterator is the first element, and if the next element exists, then we have to insert a new difference, and if the previous element exists, we have to insert another difference. And with removing, it will be different. Okay, let's not copy paste too much. So we find our position. So first it will be similar, but here instead of inserting, we will remove, erase, basically. Then we also have to, if both of these conditions are yeah, so actually here I didn't have to use lower bound. I can just insert and then I can do the same. To make it like, yeah, just use a trip. Maybe it would be easier. Probably not. Yeah, we don't need to use lower bound. And it not equal to p begin. Okay, whatever. I think this should make the code at least somewhat symmetrical. And here we can assert that we have actually found the element. So we insert this difference between next and previous. Yeah, something like that, maybe. Okay, so we have added all the stuff, and now we have to answer a query, and then sometimes we need to make changes. Changes are easier to handle, so we are given t and x. So if t is 0, we have to remove x. Otherwise, we have to add x. And here we need to answer a query. So once again, maximum of p is also, let's check. It's possible that there are 0 piles of trash. Okay, so if let's say the set of differences is empty, then we can just output 0 because the answer is 0. Because we have at most one pile, so it's just 0. And otherwise, we can find the maximum value of p, the minimum value of p, and the maximum difference is here. So we just output max p minus min p minus max d. And maybe this is correct, but I could mess up somewhere. It is not okay. what could that mean? Add I. I don't know why I wrote it like that. 577544849. Okay, lucky me. And 2321000 and a big number. All right, let's submit. Okay, accepted. Oh, I missed a raid from Grave K pair. Hello. Sorry for missing it. I was a bit busy with the problem, but good to see you. I was solving, and I'm still solving today's educational round. And I have just solved problem D. So, yeah, once again, so after we figure out the formula, it's easy if we maintain two sets, the set of all positions and the set of all differences. But then the biggest question is how do we quickly update these sets? So these functions are a bit tricky, and they are the hard one, the hardest part of this solution. Does anyone have a better idea on how to implement this? Read it because you haven't solved E, F, G. Okay. So if there are no questions about D, then I should be moving to the next problem. Maybe I can solve them. Okay, problem E. Expected damage. We have to fight N monsters. We need a shield, durability, and defense rating. Each monster. Why are there so many problems about? So this was about bosses, and this one is about monsters. I guess problem writers like games about monsters. Monster has strength and shield has two parameters, durability and defense rating. When I fight a monster with strength D while having a shield with current durability A and defense B, there are three outcomes. If A is equal to 0, I receive D damage just because my shield does not have any durability, so I just cannot do anything. If A is positive and D is okay. So basically I have durability, and if the monster has higher or equal strength to the defense rating of our shield, then we receive no damage, but we decrease the durability. Otherwise, nothing happens. Okay. Each monster has some strengths, and we will fight each of the monsters exactly once in some order. You have to consider M different shields. And for each shield, we have to calculate the expected amount of damage. Okay. This does not look... I mean, this looks interesting, I would say. 3, 2, 1, 3, 1, 2, 1, 1, 2. Okay. And the answers are just some unreadable numbers, but whatever. So, okay, let's consider just one shield. It has some durability and defense rating. So basically we want to know, like, obviously we only start taking damage after our shield's durability falls to 0. And so until our durability is positive, we get no damage. But after it falls to 0, we get all the damage. We just get the damage from every monster. And the question is how many, it's not how many, right? But when does our durability fall to 0? It falls to 0 right after we find the 8th, right? Like once we get A monsters with strength at least B, after that our durability falls to 0, right? So I think that's actually easy. Yeah, it's kind of linearity of expectation. And yeah, I think I can try to implement it and then figure out a way to explain. Hopefully we can get it correct. Because actually, if I get it incorrect, it's pretty hard to debug these numbers. But anyway. So first of all, there are two types of monsters for our shield. The small monsters, which don't deal damage if we have a positive durability shield, and the large monsters, which do deal damage. Let's sort all the monsters. And then for each, let's also have some prefix sum array. I think we will need it. And we can actually make it just of mint type. So I am using my class for modular integers, but again, it's not too hard to implement it. So maybe on stream, I can actually even just implement the functions, but I'm a bit lazy for that. So I guess I will not do that. But in general, the hardest thing here would be to divide numbers, which would require modular exponentiation, which is still not hard to implement, but still like 30 lines. But I don't like doing that in every problem. Just to make it faster, I will not. So I have, I will need some prefix sums. Pref I plus 1 is equal to pref I plus di. And then, okay, we can just, whatever. Let's answer the queries. So we have A and B. So the first question is, how many big monsters do I have? Let's find the position of the first monster which is big in our array with lower bound. So the number of big monsters is n minus pos, and the number of small monsters is pos. And now, if the number of big monsters is less than A, then actually our shield will always have positive durability, so we will just get 0 damage. So we can just output 0. And the second question is, if we have, so now we have big at least A, right? So first of all, each big monster deals its damage with probability big over A. No, it's A over big. Because the order of monsters is not, like it's random, right? The order of big monsters is also random. Like the suborder of big monsters in the order of all monsters is also random, equiprobably. So the first A monsters will not deal their damage, the first A big monsters, and then all the other big monsters will deal damage. So actually, it does not deal damage with probability A over big, but it deals damage with probability big minus A over big. Yes, because exactly big minus A monsters will deal their damage, and that's how we get the probability. And by linearity of expectation, the expected damage received from big monsters is their total damage, which is prefix n minus prefix of position, times big minus A over big. And then we also have to calculate damage from small monsters. Let's for now consider it 0 and just see what our solution outputs to the example test cases. Because I think that some of the test cases might already match. Okay, so we have this number is correct, but this number is 0 instead of 1. Okay. And for the second test case, we have 0, 8, and some number, and we output 0. So it's actually pretty close. Okay, so to fix it, we also have to consider damage from small monsters. And the thing is that here again, we have to use some kind of, well, not some kind, but exactly linearity of expectation. Each small monster will deal its damage if it comes before the, like, okay, small monster, actually after, small monster deals its damage if it comes after the 8th big monster, right? And so now we can consider all the small monsters independently, just because each small monster, like suppose we want to generate a random order of all monsters. We have taken all the big monsters, we have shuffled them somehow, and now we will do the following. We will just pick all the small monsters one by one, and for each small monster, we will just insert it into random position in our current order. And it follows that actually, this way, we can always generate a random permutation as well. We can just create a random subpermutation, and then we insert all the remaining elements into some random positions. And so basically, it means that we don't need to care about the order of small monsters between them. And we only want to know if, like, what the probability is that a small monster will be inserted after the 8th big monster. And so let's say, so we have some big monsters. So here's some position. Then we have some big monster, some another position, some big monster, another position, and so on. Another position, big monster, and another position. So we have big +1 positions. And there are A over big plus, okay, so there are A bad positions, and big +1 minus A good positions. Good means that the small monster deals its damage. So we know the probability, and so it turns out that the probability is big +1 minus A over big +1. So we take all the damage from the small monsters, which is pref of pos, and multiply it by this probability. And I think now it should be correct. We have actually not used the small variable, but Okay, we can remove it. So now the answer to examples is correct, so we can submit. Yes, this will be on YouTube. I think I went through the solution pretty cleanly, so I will not get back to the solution. Actually, the code is very short, so the hardest part is the formulas, but they're also not very hard. So this is not a bad problem. I think I enjoyed it slightly. And now we have f and g, and f has 2 solves and g has 36 solves. And we are at place 38. Cool. And yeah, it seems that f is easy. G is easier, right? But we can just still go for f. Yes, I'm going to do round 670 after this one. I'm given 4 integers n, m, l, and r. And the tuple is good if x1, x2 form a segment, one y2 less than y1, okay, and the product is equal, and the products are equal and between L and R, okay. And for each x1, we have to find a good tuple. Okay, I mean, there's some bad stuff going in the chat. I would just say that it's pretty meaningless to assume that I'm going to make a lot of money out of these videos or streaming or whatever. It's not like I'm going to make it my job or just like trying to make so videos and then just reach 1 million subscribers and make like millions of dollars or whatever. I mean, it just doesn't work that way, and I'm not aiming at that either. So it's just not too clever to assume that I'm here to make money, right? Okay, I should focus. I have N, M, L, and R. Yeah, this problem does not look easy. It takes some... Maybe I should read G first, because G is easier. So we have an array, and we have subarrays. Okay, subarray is good if every integer that occurs exactly thrice. And we have some good subarrays here, and we want to find the number of good subarrays of the given array A. Okay. Interesting. How can we do this? Yeah, I forgot to mark E. Thanks for reminding. This problem looks interesting. I have 40 minutes left, but if I cannot finish in time, I will just continue probably. 1, 2, 3, 4, 3, 4, 2, 1. Okay. So can we count the subarrays for, let's say we fix the left position, the left bound of the subarray. How can we check if some right border is good? Also, there's different problem. If the problem was a subarray is okay, no, exactly 3 times, so it's exactly 3 times. Okay. Then it's easy. I thought for some reason I thought that each element should appear, the number of times it appears should be divisible by 3. And in this case, this problem is harder, I think. But if it should be exactly 3 times, then it should be just easy, I think. Yeah. I think it's easy to do it in n log n. 2 pointers. Maybe. I mean, okay, I think that I will just do what came to my mind first. In case of divisible by 3, we can do by hashing. I'm not sure what you mean. I'm not sure about the easy way to count the subarrays. You solved multiple of 3 before you solved exactly 3. Okay, I just don't see actually an easy way to solve multiple of 3. Yeah, if we have a solution with divisible by 3, I just don't see. All right. So I think the solution goes like this. So suppose we fix the left position of the left border of our subarray, the left, like L, right? We want to count R, like R, the number of values of R which are good. And for each value in our array, we actually, okay, so each value should appear either 0 times or 3 times, right? So, for example, if we have array like, okay, maybe we can pick some array. It doesn't matter, so let's just ignore like x is something weird, so we have some x's. Okay, so we have an array like this. So let's say that our left border is exactly here. So we start from here. And where can we have the right border? First, we can have it anywhere before the first one, if we just only consider the ones. So we can have subarrays like this. But then the next border is not good for us because we will have 1, 1, and we want to have 3 ones or 0 of them. But we can have 3 ones, so we can finish somewhere like this, right? Like here. And then we can also go here, we can also finish here, and we can also finish here. And then all the other right bounds are also not good for us because we will have more than 3 ones, right? So it means that we have 2 good segments for this value. The one which ends before the first appearance of this value, and the segment between the third appearance and the fourth appearance, right? And it means that the set of good positions is not like a segment, obviously, but well, it will be some intersection. Like, okay, so I think the easiest way for me would be to use some segment tree, which just contains zeros in good positions and not zeros in bad positions, but I'm not sure if it's the easiest way. And also I think there's another way which could be like, yeah, whatever. I should pick one way. I think that I should just stick with one way of solving it. I think I will need some kind of data structure for this one, like segment tree. I don't think we can do it without it. But let's just solve this problem as follows. Consider a 2-dimensional plane. Or should I? No, I should be lazy. Okay, never mind. I just have to choose something. Actually, let me leave for a minute and then I will be back. Stay tuned. All right, I'm back. Let's finish problem G. So one way to think about this problem is move the left border from left to right or from right to left. It doesn't matter. This is Coca-Cola. Yeah. Add. No, they don't pay me for that. So we can move from the left border, and we will want to maintain a segment tree which will contain some value for each right border. And then from this value, we will deduce if this position is good or not, and then segment tree will allow us to count these numbers. And another way to go about this problem is just to consider the plane, the whole plane of, let's say we have a two-dimensional plane with like positions. Each position is like LR, so L will be the first coordinate of a point and R will be the second coordinate of a point. And then let's say that we can just make some rectangles on this plane which denote the like pairs of left and right border, and let's say that each rectangle says that these pairs of left and right border are not allowed for some reason. And after that, if we draw such rectangles which prohibit our L and R to be in this rectangle, then we can use some kind of sweep line algorithm which goes from left to right. And again, it will maintain segment tree, so I would assume that this algorithm would be pretty similar. Like it would be equivalent to the first solution, but it's just a different way of thinking about this problem. So eventually we will want to find the number of non-prohibited positions, which is the number of non-prohibited cells on our plane, like the number of cells which do not belong to any rectangle. And we can just find the area of union of the rectangles and subtract this value from the initial n square number of cells, and the area of union can be found with the usual left to right sweep line with segment tree. Neil solved this problem without advanced data structures. And many solutions use hashing. We just want you to make stream direct on YouTube. But why? Why not follow me on Twitch? What's wrong with that? Hashing as well. Okay. Yeah, I'm probably not in the best shape right now, but let's try to do it. So let's just move the left border from right to left. And let's have some segment tree of size n. We'll figure out what we maintain there later. Let's make all the values from 0 to n minus 1, right? Because all values from 1 to n, now we have 0 inset values. We will maintain the positions of all elements. So now our element is AL. And we add L to the set of all positions of value V. And now we have to modify something. Basically. Let's just put ones into all bad positions, all bad right borders. So we have two options. So first, before we put V, I don't like it. I don't like the right to left is better. Yeah, I want to go from right to left. Sorry, it's a bit hard for me to focus. Anyway. Okay, so bad right borders go from first occurrence to the third occurrence, right? And also from the fourth occurrence to the end. So these like two segments are bad. So here, no, I don't like it at all. I just have no idea what I'm doing. Yeah, I froze somewhat. Yeah, I am pretty tired. Maybe I should finish after the educational. We'll see. Position size is at least 4. No, what? Remove previous segment and then new of V. No. Focus. So if size is at least 4, so again, what do I want? I want to have good positions or maybe bad positions. What should I maintain? Okay, let's maintain the good position somehow and then we'll figure it out. So, and also for each value, let's say that it appeared at position n, just to make it easier. So if we have at least 3 positions, actually at least 4, I guess, then int third is equal to position of v and fourth is here. And so we just modify from third to fourth minus 1. We do something. We'll figure it out. And maybe something like this should work. Yeah, I just don't know. maybe something like this. If maximum is n, then add count. And segment 3, so I have a note here. I want to have segment 3 which allows lazy propagation, which allows lazy propagation, which can find a maximum and which can also count maximums in the range. So I have value, I add to both the add is the propagated value, the value to propagate, and the count should be 1 initially. And so unite is maximum of its children, and the number of maximums is just count those equal to maximum. And here we need this and pool. Yeah, someone asked about pool function. This is just colon unite, so it doesn't make much sense to have this function as a one-line function, but I'm not sure. I made this design several years ago, and so far I haven't put much thought into it afterwards. Let's see. First of all, does not compile because it should be L. And I think that I will actually get assertion error. Now it's a different error. Out of bound exception, index 6. But I should get assertion error too later. Yeah, because it's position v.size and not position size. That's not a good bug. Should be careful. Yeah, so I get assertion error because here well, basically I should only do this if positive, because I shouldn't do changes on empty segments. This is 3, this is 0, and this is 1. Okay, maybe I guessed all the changes I needed to do. How does the compiler show out of bound error? The compiler does not, but yeah, I set the link. Maybe I can send the link again and make a comment. 1 second. Okay, we got accepted, by the way. Okay, so I think this blog post contains pretty much all of the flags I have, so you can check it out. Check the link in the chat. So this one. So in particular, to get runtime errors like this, attempt to subscript container with out of bound index 7 if you're using vector or whatever C++ STL containers. You can just if you use this option, then you can get those mistakes when you run your solution. Okay. So my solution, yeah, it's actually pretty short eventually, but if prefix 1L is good and prefix 1R is good, can we say subarray L plus 1R is good? Well, obviously not, right? Because if we have, or not obviously. Oh, is it actually, what? It cannot be true, right? Or can it? Yeah, it actually can. More algorithms should not probably work because the constraints are quite high. Because we have 500,000. It's quite a lot. And also, you don't have any queries, so I don't think you can do it. Push is the basic segment tree lazy propagation function. If you have some value which you should propagate to your children, so push is called whenever you go from a node in segment tree to its children before you go to the children. So if you want to go to your children and you have some value which is not propagated yet, you have to apply it to your children and set the value to 0. Yeah, I think I will update my GitHub library later. Thanks for reminding. So, yeah, so my solution is basically, I want to find the, okay, so for each value in the array, I want to know which right borders are good. So suppose we have fixed our left border, so which right borders are good? The good right borders are all before the first occurrence and those between the third and the fourth occurrence, right? So here I mark those with the right brackets. Those are all the good values. And then I will go from right to left. I want for each value to have, so I have 2 segments of good positions. I want to add 1 on these 2 segments and add 0 on all the others, on all the other positions. Okay, so I want for this particular value, I will want to have 1 1 1 1 0 0 0 0 0 0 0 0 0 1 1 1 1 0 0 0 0 0 0 0. And 1 here means that this position can be the right border for this value. It does not interfere with the definition of the problem. And 0 means that we cannot use this right border because of this value. This value is 1 in this case. So I want to have these 2 segments for each value, and then I will put all these segments into a segment tree. And if a position eventually, I just add all these couples of segments into, I put them all into one big segment tree. And I want a position to have the value of n. Because we have n distinct values, I want the position to have value exactly n, so that if the value is n, it means that all the values are good with this right border. And if the value is smaller than n, then it means that this value is not good for some. This right border is not good for some value. So eventually, I want to count the number of positions which will have the value of n in this segment tree. And so I have a segment tree which allows to add some value to some segment, find the maximum, and find the number of maximums. It's easy to write this segment tree. And the question is how to modify it and how to make queries. So making queries is easy. So suppose I have some fixed left border and I want to find the number of right borders. And then it's easy. I want to just make a query to segment tree from L to n-1 and find the value of maximum. And if the maximum is less than n, it means that all right borders are bad for us. So we don't have to add anything to the answer. But if the maximum is equal to n, we just add the number of maximums to the answer. And this is the number of maximums in this case means the number of right borders which are good for us, for this left border. So if I add the number of good right borders for each left border, if I add all these numbers together, I will get the number of good segments overall. And the question is how to modify. And again, this part and this part are similar. They're actually the same, except for this one if, but I can also put this if here and it will not change anything. And here I have -1, and here I have +1, because I want to roll back some changes for this value, because when I move the left border by 1 to the left, I only change something for one value, for the value which I met. For all the other values, nothing changed. But for this value, I have to roll back the, like, I find 2 segments for this value. I subtract 1 from those segments in my segment tree. Then I update the set of positions where this value occurs. And then again, I do the same thing as here, but with a different sign. So to make it nicer, I can even write it like this. So not to make any copy paste, I can write coef here. I want to update with -1 coef and then update with 1 coef. So this code will be short. How do I handle a segment tree which doesn't need lazy propagation with my segment tree template? I just don't do lazy propagation. If I didn't have lazy propagation, I would just make the push function empty. And this way I have a segment tree without lazy propagation. Easy as that. Okay, so here the question is why I update like this. So basically it's easy to see. So if I have at least 4 elements, 4 because I also add a dummy occurrence of each value at the rightmost, like at position n. So if I have at least 4 occurrences, I have this segment. So I find the third position, which is actually contained in size -3 element, because the positions are stored in the vector from right to left, right? Because I go from right to left and push them back. So they will be saved in a different order, but whatever. So third will be maintained here, and fourth will maintain here. And I just take the segment from third to fourth, and I add coefficient to this segment. And finally, I want to have the segment from until the first occurrence. So I just, if it's not 0, just to make this segment valid, I just from 0 to this position, I just changed it by coef. Okay, that's kind of the solution. So from where did you study segment tree? From a lot, well, I think that I actually studied it from other people, but it was very long time ago. Right now, I think you can find a lot of tutorials on segment tree. It's also, it's quite a basic data structure, but it's also, it also appears quickly, it also appears pretty often in this segment, in this contest, whatever. I have to finish soon. Why don't I use global arrays? Yeah, Codeforces EDU section. Yeah, obviously, I wanted to say, I was about to say that. Codeforces EDU section, I think it now has the segment tree tutorial. And it has video lectures and practice problems. So you can definitely check it. So it is here. EDU courses, let's check. EatMo Academy, and segment tree part 1, segment tree part 2. You can go into the course, you can go into the lectures, for example. So here we go into lesson 4. We have a video, we have a text explanation, and we can just We can just watch it. Can we? Hopefully we can. Yep. So definitely check it out. All right, that was problem G. Yeah, global arrays. I think the global arrays are, I just don't like them. I like to have everything locally, and also functions, local functions, the ability to create functions like this helps it a lot. I just think that locals are better for a bunch of reasons. It's hard to debug global arrays. Well, with debug function, obviously, that's true, but that's not the main reason, I think. Best for beginners? You mean global arrays? I'm not sure about that, but it's hard to say. Okay, F. We have 4 minutes, but I don't think we can finish it in 4 minutes. But I think the current plan is to solve more problems. Best for beginners, I see. Okay, so I think I will finish problem F and then finish the stream today, because I actually feel pretty tired and not as good as I would like myself to feel. So I will just, let me change the title of the stream to just educational round. And then we'll go for the last problem. Okay. So tuple x1, y1, x2, y2 is good if x1 is less than x2, y2 is less than y1, the product is equal, and the product is between L and R. So the products are equal is the same as the ratios are equal, right? So we can say that x1 over x2 has to be equal to y2 over y1, right? That's one thing. But I'm not sure if it makes it easier. So we have fixed x1, and we want to go from there. Okay. So once again, we want all these conditions. Doesn't copy well, whatever. x1 times 1 y1 is equal to x2 times y2. So x1 over x2 must be equal to y2 over y1. Right? Right. So let's say that we have, so I think that, so let's fix xy. So we fix xy, x1. For each x1, we have to find any good tuple. Okay. So let's say that we know the greatest common divisor of x1 and x2. And I think that we can actually fix this value So we fix xy, and then we can loop over the value of g. And I guess it is easy to fix it, because the number of pairs x1 and g is n log n, because g should be a divisor of x1. So we can simplify the left, like this fraction, into this. And it basically means that we can have x1, let k be x1 over g, so we can have fractions k over k plus 1, k over k plus 2, k over k plus 3, and so on. So any fractions. Too late. Anyway, let's solve it. So we can have any fraction. Now the question is, can we find, so we can have fractions of form k over k plus t for some t. And then if we want to, like, k over k plus t to be equal to y2 over y1, it is equivalent to saying that y2 is equal to k times, I'm running out of letters, but anyway, and y1 is equal to k plus t times p, right? And we want k plus t times p to be not greater than m, and we want L. This is the condition from the statement. So x1, all right. We can also actually divide by x1 here and just do it like this, because we have x1 fixed. So we can have it like this, this equivalent. And y1 is equal to k plus t times p, okay? So now the question is, why would we need, I guess I'm missing something. But why do we need p at all? I'm just not sure. I guess we have some conditions. Maybe x2, actually x2 should not be too large. That's important probably. Okay. So k is constant, right? So we know k, we know g, we know n. So, okay, I think these are the only conditions. Maybe I'm missing something. Yeah, okay. Yes, we do need p. k plus t times, well, okay, I guess. So the question, oh, actually, I know k, right? Yes, I do know k. So the question is, I want to find some values of t and p so that these two conditions are satisfied. And if I can do it, then I'm fine. Let's try to make a stupid solution first. Okay, not to mess up with something. So okay, I guess people in the chat teach me some good practices. So we go. It's easier to loop over the g value first, because after we fix the g value, we can just loop over x1 easily. Okay. Mean v is less than or equal to k plus t times p less than or equal to max v. So mean p has to be mean v plus k plus t minus 1 over k plus t. And max p is equal to max v over k plus t. So if mean p is not greater than max p, then we just choose p equal to mean p, for example. And x1 obviously is x1. Okay, so x2 should be x1 plus t times g, I think. x1, 1. Okay, this is y1. And y2 is k times p. Okay, so maybe this is at least correct for the samples. Let's see. Okay. Okay, so this is different from the expected answer, but I think it's still correct. Oh no, it's not correct. No, it is correct. Is it? Is it? Is it? I think it is. Yeah. And here again, it's a bit different, but It's probably all right. So unfortunately, I think this is too slow, right? Or actually, is it? Yeah, I think it is. We can have a huge test case, like 1, 200,000, 1, and 200,000 squared. Oh no, it should be 200,000, 200,000. Yes, obviously. Yeah, this is still slow because we loop over t here. But if this loop was not a loop, then we would be fine. Can we eliminate this loop? That's the question now. I'm not so sure about this, but yeah, it should be true. Should be possible at least. Yeah, so I want to find the integer t so that this inequality has some. Actually, let's just submit for now and see if I get time limit exceeded on test case 4, just for fun. Have I guessed it right? Have I? Okay, probably. I can even mark it as red. Wrong answer on test 24. No, I think it's time limit on test 4. Sorry. Not even wrong answer on case 69. Okay. How do I find this value of t? I can also write break here, right? Or even optimize it like this. Yeah. It should still not be good enough, but maybe I can pass test case 4 now. Yes, pass test case 4. TLE on test case 5? It seems so. Oof. Oh, TLE on 26. Nice. So at least our approach is correct, but it's a bit slow now. Okay, so at least one thing I can see here is that maybe we can loop over t or over p, because the product of t and p is not greater than m, which is 200,000. So I think that we can get n log n times log n times square root of n complexity, at least here, if we loop over t or over p, I think. This is not like, I don't like this that much, and I'm pretty sure that better complexity should be possible. But I think that this might actually get it accepted at least. Minimum plus k plus t minus 1 over k plus t. How can I quickly find out if this is less than or equal to this? I don't actually see it. Or maybe do I? No, I should. It should not be hard. So actually t should be a value such that k plus t is a divisor of some number between min v and max v, right? Right. How do I quickly find out if what values of t I can pick? I don't want to factorize numbers between min and max. Okay, let's do the square root, n log n square root of n solution. So what if t is less than or equal to p? Let's remove this optimize of no solution found yet. But maybe maybe it can be fast enough without it. So let's say that t is not, t is not greater than p. So I want k plus t times t to not exceed max v. And here it follows that the number of values of t is at most square root of n. And what if t is greater than p? Then I can loop over p. Can I? Yes. I guess I should go from 1 to max p. What's max p? I don't know. So it should be k plus p times p, not greater than max v, right? Let's say it can be equal here too. I think it doesn't matter. The pragma optimizations, probably not. But I usually don't use them anyway. But yeah, I don't know. I don't feel like trying. And so I will have new min t and new max t, because I have some old values and I will update those. So I will pick t equal to new min t, and new min t here is, if I divide over p, divide by p, so it's like this. So here it's ceiling, here it's floor. So I want it to be maximum of min t and min v plus p minus 1 over p minus k. And this should be minimum of max t and max v over p minus k. So I think this way should be okay. Okay, here I should have p. Okay, looks quite slow. Is it too slow? But I don't see actually why. Okay, what if I have 20,000? Okay, 50,000? Okay, let's maybe then, in this case, let's just try to get accepted. And maybe someone can hack us. And have a good time. But I think I will just try to get accepted right now. And then maybe I'll read the intended solution. Okay. My Chrome froze. Sad. Yeah, far is barely an ID. I agree with that, and that kind of proves that ID setup doesn't matter. Or how people on Twitch say "sad." Should I use Firefox, Mozilla instead, or what? Okay. Really? Okay, sure. But it didn't close. It was only the window of opening file. I'm not sure why. Okay, accepted. But maybe someone can actually hack our solution. Everyone is welcome to try. And there is no editorial yet, right? Is it actually posted after the hacking phase? Can anyone tell me? Because I think that I have... No, probably it can be posted earlier, but just not ready yet, right? Okay, problem F. No comments. How to solve F. Oh, how to solve F. Nice. It's after hacking? Okay. Fix GCD. Okay, that's the same. We have two cases. Keep a binary index tree. Okay. I guess you can do it in nlog square, but it will be a bit harder to implement. And this is, well, this is n square root n log n square root of n. But it seems pretty slow because these division operations are not fast. N square root of n log n divisions is quite bad. This message in stream looks scary. Yeah, I'm not only doing math problems, but this problem is quite messy. So I'm usually doing any competitive programming problems. It's just this one. Whatever. So let's mark problem F as solved. And okay, guys. So today I managed to solve 7 problems in 2.5 hours, I guess, which is not the most exciting result. And unfortunately, I don't feel like doing another Codeforces round 670, which I was planning to do afterwards, but I feel pretty tired today. So I think I will wrap it up here and call it a day, or maybe a night. Thanks everyone for watching. I hope you enjoyed this stream, even though it was not the best one. And I think I will do some similar streams later. So for example, September 19th is the next Division 2 round. And yeah, I mean, possibly I will tune in right after this round like I did today. And also hopefully this round will be rated. And hopefully every round will be rated afterwards. Yeah, but in any case, I will post updates about future streams in my Codeforces blog. So be sure to follow it and check for new blogs and schedule updates. Yeah, and the next stream will be on Twitch anyway, so sorry about those wishing it to be on YouTube, but I will definitely post my video to YouTube as well. Okay, so please share the resources. Codeforces.com, perfect resource. Isn't it? What was it the question? Codeforces.com. Google.com, yeah, Google.com is a great one. I agree. It has a lot. What about Yandex rounds? There were 5 of them, and the Snark News series has finished, so I will not do those for until winter, I suppose. Okay, whatever. Thanks a lot. Be sure to follow me on Twitch to see future updates, and you can check my YouTube for the previous streams if you feel like watching them. Thanks a lot for watching, and see you all later. Bye bye.